Hello and welcome to a lesson on Pythagoras Theorem. In this lesson I'll explain what Pythagoras Theorem is and we'll look at 5 examples of how to use it. To begin then, given any two sides in a right-angled triangle, we can use Pythagoras Theorem to find the third side. So Pythagoras Theorem is a relationship that connects the lengths of the sides of right-angled triangles, but the triangles must be right-angled. Here's a statement of Pythagoras Theorem. A squared plus b squared equals c squared, where a, b and c are the lengths of the sides of the right-angled triangle. However, the one that goes on its own in this relationship must be the side we call the hypotenuse of the right-angled triangle. Well, which side is the hypotenuse? It's the longest side. It's the one that is opposite the right angle. It doesn't help make the right angle, as those two do. It's the side that's as far away from the right angle as you can get. And that's crucial when we state the relationship, because the one that goes on its own is not always the side that we're looking for. Right, let's have a look at our first example. Find x. Now if we're going to use Pythagoras theorem, we should say by Pythagoras to say that that's the theorem that we're using. And here I've got a triangle with a side 3 meters and a side 4 meters, and I'm trying to find the third side, x. Well, the first thing I'm going to do is mark on which is the hypotenuse. So the hypotenuse is the side opposite the right angle. In fact, it's the x that we're looking for. So when I state Pythagoras theorem for this triangle, it's this one squared plus this one squared is equal to the hypotenuse squared. So 3 squared plus 4 squared is equal to x squared. Now this is a nice easy one with simple small numbers. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25, so 25 is equal to x squared. Now if we know what x squared is, to find x we take the square root. So if x squared is 25, x is the square root of 25. And the number which multiplied by itself gives you 25 is 5. So x equals 5. And for this last line I'll write the x on the left hand side. X is equal to 5. 5 what? Well, these lengths are in meters, so x will be in meters. So we've used Pythagoras theorem to find the length of a side in that triangle. In most examples, the arithmetic is not as simple as that. And when applying Pythagoras theorem, we normally use a calculator. This would be a good time to pause the video to get your calculator to hand to make sure you know how to enter in the data for Pythagoras theorem type problems. I have here a model of a scientific calculator, and we'll use the simple example we've just been looking at to see how to enter the data in. So let me write down first that x squared is equal to 3 squared plus 4 squared. And we know from working it out by mental arithmetic that the answer was x equals 5. So what we need to put in the calculator is 3 squared plus 4 squared to start with, and then we need to find the square root. Now every scientific calculator has an x squared button, and I've put a box around it here to show where it is on this calculator. Not all calculators have a square root button dedicated to that function. This one doesn't. For this one, you have to press the inverse button, and then there's a little purple square root sign on the same key as the x squared. But a lot of models of calculator have a separate square root button. So let me go through the key presses for this calculator. We have to type in 3, and then to get the 3 squared, we just hit the x squared button. Now I want to add, so it's plus 4 squared is 4 followed by the x squared button. And then I need to hit the equals button. And at that point, In the proceedings, I will have x squared equals, I'll have 25 on the screen. And now I need to find the square root of that. And on this calculator, you type in inverse and the square root sign. So it's the INV, the purple button INV, followed by the square root sign. And as soon as I've hit the square root sign, the answer will come on screen and it will be 5. Now in some other makes of calculator, you won't need to have an inverse button, you'll just press the square root sign. But you might also have to press the equal sign to get the answer. So you just need to watch the screen. When you hit the square root sign, if the screen doesn't go to an answer, you hit the equals button. But if when you hit the square root sign, the answer comes up straight away, you don't need to hit the equals button. Right, let's move on now to look at another 4 examples. Example 2. First thing I'm going to do is mark on the hypotenuse. That's the side that is opposite the right angle. So it's the x that we happen to be looking for again. And then I'm going to write by Pythagoras, because I'm using Pythagoras Theorem, and it's this side squared plus this side squared equals the hypotenuse squared. So it's 5 squared plus 12 squared equals x squared. So now we need to work out this left-hand side, and we can do that on the calculator. We can type in 5 squared plus 12 squared equals, and we get 169. And now I want the square root of 169. If x squared is 169, x is the square root of 169. So on this calculator, it's inverse the square root sign and up comes 13. So let's write the x on the left for the final answer. X equals 13. What are the units? Well, the two measurements here are in meters, so x will also be in meters. Example 3. By Pythagoras, well, what is Pythagoras' theorem for this triangle? First thing to do, make sure we know which side is the hypotenuse. That's the one that goes on its own. So it's x squared plus 8 squared equals 17 squared. X squared plus 8 squared equals 17 squared. So this is the first example we've looked at where the side that we're trying to find is not the hypotenuse. So it's not the one that goes on its own in this relationship. But I want to get x squared on its own. So what I need to do is take the 8 squared to the other side. So it'll be x squared equals 17 squared, but when I take plus 8 squared to the other side, it becomes minus 8 squared. So we've got a different relationship now. We're not adding two things together to get x squared, we're doing a subtraction. But we can feed that into the calculator the same way. We can say x squared equals, and type into the calculator 17, hit the x squared button, minus 8, hit the x squared button, equals, and that comes to 225. So if x squared is 225, x is the square root of 225. So I simply hit inverse square root on this calculator and it says 15. Check the units. The two sides given were in centimetres, so the answer will also be in centimetres. So the missing side, x, measures 15 centimetres. Two more examples. Let's say by Pythagoras to start with. Acknowledge we're using the theorem. Mark on the hypotenuse so we can see which one's going to go on its own, and this time it's the x again that's going to go on its own. So it's 6 squared plus 19 squared equals x squared. 6 squared plus 19 squared equals x squared. So let's have in the calculator 6 squared plus 19 squared, 6x squared plus 19x squared equals 397. So x is the square root of 397. So on this calculator, inverse square root sign, and it's not a whole number. Indeed, the answer to Pythagoras problems doesn't have to be a whole number. And to one decimal place, I'm going to say x is equal to 19.9. 19.9 what? Meters, because the other two measurements are in meters. Moving on to our last example. Using Pythagoras, or let's say by Pythagoras, mark on the hypotenuse so we know which one goes on its own, and it's going to be x squared plus 18 squared equals 23 squared. So we see this time we're not trying to find the hypotenuse. The one we're trying to find isn't the one that's on its own. So let's get it on its own by taking the 18 squared to the other side, and we'll have 23 squared. Take the plus 18 squared across and it becomes minus 18 squared. Feed that into the calculator. 23 squared minus 18 squared equals 205. So we now find the square root of 205 to give us x. So I'm pressing inverse square root sign, and again it's not a whole number. X is equal to one decimal place, 14.3. 14.3 centimeters, because the other two sides are in centimeters. And that concludes this lesson on Pythagoras Theorem. Always acknowledge you're using Pythagoras Theorem and write it out for that particular triangle. One side squared plus another side squared equals the hypotenuse squared. And remember, if you try to find a side x, it's not necessarily the one that goes on its own. There are now 10 questions for you to have a go at in an exercise.